Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And this is today's very easy other type puzzle, and it's a Minesweeper puzzle. And the title is called Sweep the Floor by Flora. And let's get to the rules. We have classic Minesweeper rules apply, where we need to shade some cells, which are mines, so that each number represents the total count of shaded cells in the up to 8 neighboring cells in the up to 8 neighboring cells. Cells with a number may not be shaded. No 2 by 2 area may be fully shaded. So for example, this is a 2, oops. That means there must be 2 mines in the up to in the 3 by 3 area that's surrounding that's centered, I should say, on this cell. So we could have something like this, which would be valid, which would satisfy this 2 here. And no 2 by 2 area may be fully shaded. So you cannot have a 2 by 2 area which is like this. That's not allowed. What else do we have? Draw a path between the 2 brooms. The path may not go through any shaded cell and must go through all unshaded cells, including cells with a number on them. The path may also not touch itself, not even diagonally. Interesting. So we have to draw a path between the brooms. The path cannot go through a mine, cannot go through a shaded cell, and they must go through all unshaded cells in the puzzle. So, for example, we could have the line has to go through every single unshaded cell in this puzzle. So it could do something like, I don't know. It cannot branch, so we can't do this. It cannot touch itself, not even diagonally. So therefore, it could not do something like this, because that would be touching itself diagonally. So it could do something like that. This is technically a legal path. It's very unlikely, though, for that to be a path, because we know no 2 by 2 area is fully shaded with mines. So there's that issue, too. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Or, we haven't done this. Let's go. Okay, so we know this has to go that way. I think it's surface. So 2 out of these cells have to be a shaded cell. So this has to be a shaded cell because it can't go back and touch itself there. One of these 2, it has to go through. So that means the other one has to be a shaded cell here, which means this cannot be a shaded cell, so it must go through that cell there. So these are valid cells. Obviously this is valid. This is valid, 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 valid here. This has 3 that are valid here. And it must be the 3 that... So 3 of these are going to be shaded. 3 of these are valid. And it has to be orthogonally connected to the 3 coming in and going out. So it cannot go here because then that's blocked going that way. So therefore it must be valid, valid, and then these are the shaded cells here. So then the line has to go this way, and it has to go through here. It cannot touch itself, so it must go through there. So surface, that's valid. This is valid. This cannot be, because that wouldn't be considered touching itself. This is not valid either. This would be touching itself. This would be touching itself. It has to eventually get to here. So it has to go here and then go to one of these two cells here. So then the line goes here. It must connect to one of these two, and then it must exit out. So one of these two is shaded, one of these is not. So we have 3 unshaded here. The 4th one goes out, so the 5th one cannot be, must be orthogonally. The 4th digit here must be orthogonally connected. So these cannot be. These are all, how do you say it? Mines. This has 1, 2. It cannot go this way, because if it went this way, the problem is it can't exit out that way because it's a mine. And we have 3 here. That means the 4th one has to be orthogonally connected. So therefore, these cannot be. And this must be a 4th mine going there. So then the line connects to here. We have 4 around here. We have 2 here. This is a mine here, because you cannot orthogonally connect. Oops. So this would be mine, mine, mine there. That means 2 out of these 3 have to be non-mines. So therefore, this is guaranteed to be a non-mine because it has to go either this way there or this way there. So then that has to go that way. It cannot go, this cannot go that way because then it would be branching. So this must go here, which means these are both green. So it has to connect here. This is not valid to connect that way because it would be considered touching itself. So then it has to go that way. These then are all not on the path. So the line has to go this way. That means this has to be green because no 2x2 area is all shaded, which means it must go in and exit out that way. No 2x2 area is all black. So we have green there, green there. This must be black here then. So we have line going here. Oops. Path goes that way. This must be entered and exited that way. So we have line here. This cannot be valid because it would consider touching itself. So this has to go this way. So then it connects there. So these are not on the path. Oops. So these are not on the path. That means it must connect up to here. So the line goes this way, goes here. Oops. This 6 also has 1, 2, 3 cells enter and exiting. So it must be only orthogonally. It cannot go to any of these. So this is not on the path. Neither is that. This can't be anymore either. So it must enter and then exit here. If it exits this way, it cannot go here and then go back on the path. So therefore, it must exit out this way. Because otherwise this 2x2 area would be all shaded. So this has to go this way. If this part has to connect to the broom because it's going to go here, right? So it has to connect to the broom. So this cannot go this way because if it did, it would not connect to the broom. So this has to connect that way. So this is not there. That's not valid. This is shaded here. That has to go here to connect to one of these two. We are not going to be able to get to 2 from here. So therefore, this has to go here. And this is connecting to the 4, but we need to connect to the 2 before we get to here. So this has to go this way because it cannot touch this. So none of these are on the path because it would be considered touching it. So it has to go that way. So it connects to here, and then it has to go here. That means this can't be on the path. Oops. So then this has to go this way. Cannot reach here because that would be considered touching it. So therefore, this can't be considered touching it. So therefore, has to go this route. This has to go this way. This is a 2x2 area that's all dark. So therefore, this must go that way. So therefore, that's not on the path. This is not on the path. So we have the line going that way, the line going this way. This has to go here. If we go this way, this is going to both be black if that's the case. So we have to go this way then. So this is not on the path. This can't be because it would be considered touching it. So we have to go this way through to the 2. This is then the line because it would be considered touching it there. So that would be that way. So that's 4, which is satisfied there. This only has 2. We have 1 here. And if we go this way, you cannot go that way because that would be touching itself. So it would have to go here if it goes that way, which would mean this has 2. This has 3 mines if that were the case. So this cannot go this way. This has to go here, then here. It cannot touch itself, so then that would be done there. So this is the last one, and this is the path here. Yep, fairly straightforward. Not too bad into figuring that out. What are the numbers, actually? I'm kind of curious. So this would be, this sees 1. So we have 1 there. Can't see it. I think that's green. Let's remove the line. So what would the Minesweeper be then? Let's make it dark. So this would be 1. This would see 1, 2, 3, 4, 5. This sees 4. That sees 5. This sees 2. This sees 1. This sees 3. We have 4 there. This is 6. This is 4. 5 there. This is 1, 2, 3, 4, 5 also. This sees 4. This sees 2. We have 2 here. This is 2 here. 5 here. This sees 6. This sees 5. 3 there. 1 there. 2 there. 5 there. 5, 2, 2. 3, 1, 1, 3, 4, 5, 5, 4, 6, 5. That's 6. 4 here. 1, that's also 6. 5, 5, 5, 4, 4, 5. Actually, this is 5 too, also. We have 5 there. 4, 5. This is 4. That would be 2, and this is 3. Interesting. Yeah, so the Minesweeper actually wasn't that important. We weren't trying to fill out the grid with Minesweepers. We were just using the Minesweepers to figure out where the shaded cells were, essentially. And that's it. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.